So the title of the talk, Optimizing Dagger on Android. First thing, obviously you can't optimize anything until you actually know what's going on. So if you've never used Dagger before, unfortunately this isn't the talk for you. Though I gave a talk with David Baker, who also is on the Dagger team at Square back in February. The link will be in the slides. Highly recommend looking at that if you want to get sort of a baseline for what we're going to be talking about today. You definitely don't have to have watched that, but it does. We will be building upon some of the ideas. Great. So some prereqs, you have to use Dagger before, or at least understand dependency injection. Hopefully you've seen that talk or will see it in the future. And you're not scared to look at generated code. We take a lot of effort at Dagger to make our code as readable as possible to use. It's still machine generated, so it's not like the most pretty. But if you don't look at the generated code, it's going to be very hard to optimize what you've got. And this is not going to be so helpful for you. So please, IDEs do a good job of linking to all this code. Take a look at it for the same reasons that you look at AOSP source code. It's helpful to sometimes understand what's under the hood. So let's just go over a few terms that will be helpful throughout the rest of the talk. So first, we have the concept of a key, which is a type and an optional qualifier. This should be probably pretty obvious to everyone.
And a binding is the conjunction of a key and a set of dependency requests, and you might ask what a dependency request is, and we'll discuss that in a second. So let's give a simple provides method that creates an airplane. I apologize in advance. I think it's a little bit of a better example than a coffee maker, but DI examples tend to be pretty terrible across the board, so we'll try our best. So we're creating an airplane. And an airplane can have the general body that goes long, and a left wing and a right wing. And so in this example, there are a few different keys. There's the airplane, unqualified, the body, unqualified, and then two keys for the wings, one left and one right. The left and right keys are completely separate. And then we have a concept of a dependency request. So for this provides method, it has 3 dependency requests on the body, the left wing, and the right wing. So each has a key, but they also have a kind. And what are those? It's either an instance kind, provider kind, lazy, and if you use producers, there are a few others. What exactly does that mean? Oh, sorry, I jumped ahead. If you ever request one of our wrapper types, like a provider of the body or a lazy of the body that only gets executed separately, those have they're the same key but a slightly different dependency request. Okay, so when I mentioned that the key is a type, it's not fully true. We do normalize it a little bit. We box up ints or all primitives into their boxed kinds. And we also will strip, if you have a provider or lazy, back down to the inner type there. So here, if we have an X-wing for the Star Wars fans out there, which has, let's say, the same first 3 dependencies, but instead of just one left wing and one right wing, it takes a provider of left wings because you need 2. Those have the same keys as they do in the lines above. And then if we have a logo, that's one key, which would be the same as if we had a lazy logo. Same exact key, same binding that gets used when you look up that dependency request. Speaking of, let's walk through the life of a dependency request, sort of understand how Dagger works when it begins to implement your generated code. So first, obviously, we have to look up how many bindings are in this key. This should be familiar to everyone. If there is 0, you get a missing binding error. If you have 2 or more, you get a duplicate binding error. We know these errors aren't the best, and if you have suggestions, we're always looking for that. Assuming that you have a valid graph, though, you have 1 binding for that key. We ask one question. How can this binding X be represented in this particular dependency request kind? So one binding, let's say for the right wing, will look one way when it's requested just as an instance and look slightly different as a provider and slightly different as well for a lazy. So let's take a look at some of those. So we have our airplane module, and takes a body, a left wing and a right wing, and a welder. For those who, I'm not going to try and have a thermosiphon in here, but welder, something attaches metals together for the sake of this talk. And a lazy safety feature. So here's the body of the method. Not so important, but let's see how this actually gets implemented in code outside of the contents of the method, but from the perspective of the dependency requests. So we have our component, and we're going to traverse in from that one component method, a few modules. Okay. So when we implement that create airplane method, we're going to need 5 parameters, just like the provides method. So let's start one by one. We're going to need the body object, obviously, and a body object needs steel. So you can notice right away that this all happens recursively. Left wing also needs steel, right wing needs steel, and a logo, of course. And then we have this welder provider.get, which is a little strange. A little emojis for everyone. And then even more strange, we have this double check lazy safety provider. Sorry, that get is extraneous. But we have what you would sort of expect for the first 3, which is either you call a constructor directly or call a provides method directly. And then those last 2, we have something, this provider, where does that get created? So let's take a look at what we call the component initialization, which happens every single time that you create a new instance of that component. So for each of those bindings that needs a provider, we're going to initialize. And we're going to create this wrapper provider object. And that will call the same contents as if this was requested just as an instance, but within the provider. And then because that, you don't want to use the same welder every time, those are extensive, we're going to scope that. And double check provider is what implements scope and wraps this provider instance. That'll be important later. But this isn't exactly how we implement it, because if you know anything about Android, an anonymous inner class just anywhere in your app could very easily leak that reference, the entire component. And you probably have many instances that you don't want to be sharing, especially if you have an activity component. So this is not exactly how we implement providers, even though we sort of wish we could. So let's look at how that actually happens. So first we're going to have the wire provider, and then a protective shield provider, and then the welder provider is going to concatenate all of those. I omitted the flamethrower provider, though that would be pretty cool. And so you can see just from one binding that needs a provider, we have all of the transitive dependencies up the tree need provider instances. And you're probably wondering, this is pretty boring, I don't really care, and why does this matter? So component initialization is very, very slow, as you probably all care about. Otherwise, you wouldn't be in this talk. You would say, oh, Dagger 2, it's effective for me. I don't really need to do any of this. And yes, we've made lots of improvements over Juice and Dagger 1, but it's still not perfect, right? So let's look at exactly how slow it is. And these timings are all from an example app within Google. They're not perfect. They're just what we did on a one-off. But it's important to mention that this is for an activity component. So it's not including anything for your application. So the first initialization is 200 milliseconds. Not so great, especially when an activity component is probably a little bit smaller than your application component. And then every additional initialization we've seen times at 2 milliseconds. So what's going on in that difference? Why is just the first one so slow? And the hint is how we create providers. You see that this is a 100x difference. And the answer for what we've been able to determine is that class loading on Android is very slow. For servers, this is not an issue. You just load the class. Often you load all of your classes at server startup, and for each request you see absolutely no cost. But for an Android app, especially when your app startup is really, really important, loading all these classes into memory, which never get GC'd, and take up a lot of time just to sort of process, can take a lot of time. So initially, when we created the algorithm for how to generate components, we're like, wrapper objects everywhere. We're Java developers. This makes things simple. And soon enough, we realized that too many of these provider objects is slowing down your apps, and we need to improve that. So we sort of assumed the entire time that we're going to create these wrapper objects, and ProGuard would be smart enough to get rid of them. It turns out that even a optimized version of ProGuard was not, in fact, that smart. And we are sorry for forcing that cost upon you. The point of this talk is to sort of unravel that and help you guys get back to a better state. So how can we load fewer classes? The first one is a cheating answer. The next version of Dagger, which will hopefully come out next week, if you're using the snapshot, you'll get all of these features. So let's take a look at what's coming in the next version. So let's take a set binding with two contributions, a single element and elements into set, just for fullness. So when we use that as a provider, we're going to have the set factory. That's one class, but that is constant for every amount of set factories that you need. But each contribution is going to get its own factory. You can see the difference in add and all. And for every contribution that you have to that set factory, just tack on another provider, and remember all of those transitive dependencies, all of their factories. If we can inline that, similar to how we called the provides methods or constructors directly, this is the code that we would get directly. You can see a mutable set. I'll throw in that the Guava team has been working very hard on a Guava specialized for Android. Eliminates a lot of the extra classes, obviously the key of this talk, and also performance and memory on Android devices. We've done a lot of timings, and we see that this outperforms hash set on Android. So if you were staying away from Android previously, or from Guava on Android, highly recommend putting that back into your build. So we'll use that automatically if you have Guava. If not, we'll use a hash set version. So again, the point here being, if you can get to this inline form, you save tons and tons of factories. Let's look at the same thing for maps. It'll look pretty familiar. So we have two different map bindings, two keys. The map factory is going to take each key and the factory. Again, this looks very, very similar. And again, a map builder. One additional example is binds optional of, a little bit more of a power feature, but same idea. You might sometimes have this debug logger, and every time that you request that as a factory or something scoped, you're going to get this anonymous inner class, and this is not exactly how it looks, but we'll cache that for all absent or present providers. But point being, you get more classes. But if we can get this inline form, this looks exactly how you would expect your Java code to look like. And finally, if you use component dependencies, which we'll talk a little bit later in the talk about, if we have this, I'm sorry, the text is a little small, but if you have on the left side one component, on the right side a component that depends on that first component, and uses database, obviously uses the database from the first component. So if we need uses database in a provider form, we're going to force that database binding to have a provider form as well. And that's just straight up inner class and calls the component method. Feels a little bit silly if you're getting the pattern. You're understanding what's going on. But the inline form just calls that method directly, and that's what we want to be getting to in all of these cases. The key thing here is we want to get rid of unnecessary providers. We want to get rid of unnecessary lazies, and I left off here, but we want to get rid of unnecessary scopes as well. All of these things trigger a provider instance. The provider, obviously, because it is a provider, but lazies and scopes are implemented in the same way of needing a provider. We want to get rid of that wherever possible. So we can just have our components be implemented as regular Java calls to your modules. Java-C, ProGuard can inline those very well, and you get exactly the code that you would expect if you were implementing this by hand. You're no longer going to be getting all this weird factory provider wrappers, and when you look at your generated code, it'll all make sense, assuming your tree is not crazy. So let's look at a few examples of how we can load fewer classes and get rid of some of these providers. So often, Dagger has no choice. The code that you write forces us to create a provider, like we said with scope and lazy. Here with a provider, if you're only using the provider once in onCreate, or if you're using the provider once in your constructor, you're getting absolutely no benefit, because as soon as you inject into this class, even before the constructor or onCreate method finishes, you're already calling get once. So you're not even delaying anything at all. So in these cases, magic move might have failed me. Okay. Well, in these cases, don't inject a provider. Unless you've profiled your code and you see that a provider is going to be delaying some cost and you're willing to accept all those class loads, just inject the instance directly. You're going to save a lot of, you're going to use GC to your benefit, save a lot of extra wrapper classes, and it's also just going to make your code look more intuitive. If you have this provider class, someone coming to your code is going to be wondering, what is this provider doing? Why is it injected as a provider? And that's just unnecessary complications. Okay. So just a few guidelines. If you ever inject a provider of your binding or a lazy of your binding, and you always call get exactly once, especially in the constructor and onCreate, or even later, we've seen a lot of people just inject a provider or lazy because they don't use it right away. They don't realize that they're not really adding any savings. So definitely profile your code. So if your binding isn't actually expensive to create, you're not getting any benefit and probably a lot of cost by injecting a lazy. You probably didn't realize this beforehand, because until the next version of Dagger, you in many cases were forced to use a provider instance. And again, we're sorry about that. As soon as you upgrade, you're going to see the costs of all these things change dramatically. So whereas creating a lazy instance was previously just the addition of a small wrapper object with no upstream creation of factories, now you're going to get that. So if you update to Dagger 2.12, you don't see any benefits. It's probably because you're not being intelligent about how to inject different dependency requests, and changing those could have drastic impacts on your app. So instead of all these cases, just inject the type directly. And remember, always profile your code. A lot of these cases you might not realize right away, but if you because just a few classes, you're not going to have much difference. But if you profile and you see absolutely no difference, definitely get away from the lazy, definitely get away from the provider, and you will over time see a good impact. So here, let's take a look at the lazy case. Similar example. You have a lazy, you inject it right away, you call get, done deal. A lot of people have this misconception of lazy that it's also the same thing as a scope. The one key difference is that it's scoped for each individual dependency request, unless the binding is scoped. So let's see an example of how that works. So if we have a second lazy of schedule, look, it's the same key of lazy, but two different dependency requests, same binding. So instead, if we assert, sorry about that. If we assert that the two schedules are the same, we're going to get a failure. Each of those are going to return a different instance as long as the binding is not scoped. So this shows lazy, often is not really what you think it is. So really make sure that you understand what exactly is happening when you're using that in your code. Okay, here's another example of a case where you can probably get rid of your provider usage. This seems pretty idiomatic, and in Dagger 2.0 through 11, this would have been, no cost to you. You need 4 instances of your binding. So you inject the provider, you create your array, you iterate, and then each time you call get and get a new instance. Fine. But now we're trying to get rid of providers. This is now totally idiomatic. If we just inject 4 instances, first of all, unless you have a variable amount, I would argue that injecting the exact amount of instances that you want is significantly more clear. And we're going to be able to get rid of this provider object. So instead, we're just going to create that array directly and get rid of the provider. A trivial example, but it shows that there's a fundamental difference between injecting a provider and injecting an instance. And if you know exactly how many instances you're going to need, skip the provider. Okay. So let's look at another example of how we can load fewer classes, which is reconsidering some of your scoping. And often on Android, people say, objects expensive, scary, and they just scope everything. Again, you wouldn't have seen a lot of these costs beforehand. You're going to start seeing a lot of these costs if you reconsider your app design, and hopefully you'll see a lot of improvements by removing some scopes. The key is use GC to your advantage. GC has gotten a lot better on Android, and whenever you have these scoped objects, you're holding those for the lifetime of your app or the lifetime of whatever scope that component is in. And you're also, again, forcing all of these class loads, which are totally unnecessary. So let's take an example. You have an analytics tracker, analytics scope. It has a queue of analytics that it hasn't yet sent to the server, has some flow name and some object which translates the view that you click on, and some identifier that's, let's say cross-platform. And every time that a view is clicked, you're going to add something to this queue with a flow and this translated view. And whenever you on-detach of your fragment or similar lifecycle method in your activity, you're going to flush and send all the analytics to the server. This seems fine, but the only thing that really needs any state or to be saved across different injection points is this queue. If you injected multiple analytics trackers, the flow name isn't going to, it's a string that's immutable. Recreating it, even if you're computing it, should be inexpensive. And this analytics to ID tracker, that should be stateless. So what if instead we scoped just the unsynced analytics queue? So we'll have some nice animations. Slide that down. And now notice that we just have here the provider is being created for the unsynced analytics queue and all of its transitive dependencies. Anything for the flow name and the ID translator are now out of your initialization. That should have a non-zero increase in startup speed, especially when you consider, just looking at the initial code, how you see a string, that should be inexpensive. But you don't know what providers are needed to create that string. And you don't know what providers are needed to create the view analytics ID translator. So key is look at exactly what needs to be scoped. It'll make your code a lot more idiomatic. Now it's very clear what has state and what doesn't. And now you can create lots of analytics trackers throughout your app. You don't need the exact same instance, and you're saving a lot of runtime cost. Here's another example, and I'll preface that this should be used with care, but you could have, your mileage may vary. So here we have a networking component. Networking component needs an executor, and creating that executor requires no dependencies whatsoever. So you're not really getting so much benefit from Dagger here, except from adding the executor to your graph. The problem is you're annotating that with singleton because you want the same executor across the entire component, which is the right thing to do. You don't want to be creating new executors every time they're requested. You're never going to get that caching that you want. However, that requires creating an extra double check and all of the associated costs with that. What if we can, if you're doing that all over the place, that's going to add up. So what if instead you had a binds instance method on your component. So this is an effective way of scoping. It's effectively scoping even though it has no scope annotation, right? So you have, you're passing an instance. An instance has to be scoped because Dagger doesn't have any executable code to be running for that binding. So every time you request that, we're going to just refer to that instance directly. Here's another example, by the way, of if you are using a binds instance binding as a provider anywhere, you're like shooting yourself in the foot tremendously because you're going to be creating a wrapper object around a simple instance, just going to return that every single time. It's like completely wasteful. So use this with care, but if you can get to the point where some of your bindings, which are very trivial, are binds instance methods, and you just set them on your component, you're going to save all those costs. And to make a quick side point, if you've ever seen someone add a scope annotation onto any constant they're returning from a provides method, you should jump back right away. If anyone's ever returning constant string or compile time constant in a provides method, we've seen this tons and tons at Google. People aren't really aware that scoping has a cost, right? So if calling that method is always going to return the same thing, just remove the scope, let the method be called directly. Your VM is going to merge that up. You're not even going to see the method call, and you're going to have a lot of savings. Okay, and then the last example, or last way, is to suggest better code gen. We have an experiment that probably will be synced to GitHub very soon. We don't recommend using it, but take a look at it, of a new way of generating code that one team at Google has suggested to us. I think that probably will result in potentially more memory leaks. It's unclear, but at the case of a lot of provider savings. So the point being here, and I think I forgot to mention this, across a lot of the slides down the bottom, I put all of the different files in our GitHub repo for where you want to look if you're looking to implement, or if you're looking to see how that piece of code is implemented. Point being, we've spent a lot of time trying to make the Dagger code base a lot more readable, and we really welcome contributions, and we welcome people experimenting and coming back to us saying, like, we timed stuff in our app, we made these changes, here are some benefits that we could see if we implemented this for everyone. So definitely take a look in your IDE, look at the code that's being generated. If anything looks bizarre to you, come back to us. We can either discuss and explain it to you or try and think of a better way to be generating code. So let's pivot a little bit now, talk about Dagger on Android and why exactly we want all of this, all these savings to begin with. Oh, shoot, I pressed that button again. Sorry about that. So raise your hands if any of you have ever written an activity like this. Right. So I'll include myself in that as well. We have this ugly cast to an application, which just gets us the component, and then we can call inject. That's not so bad when you're replicating that across every activity in your app, and you can't have any base class because you need to call the exact inject method, and if you're splitting up any of your code, compiling in different Gradle modules or in different Bazel packages, you're going to have some even more intermediate types. It's going to get really ugly really fast. And the most important thing is that all you care about is what's being injected. The login activity here should not care at all about where its injector is coming from, right? That's a core dependency injection principle, separation of concerns. So how can we get rid of all of this and just have the activity look exactly what it needs, have the code of just what it needs to know and nothing more. So here in that previous example is probably what your application looks like. Worth noting that probably most of us forgot to double check lock on that component. I'll raise my hand and say that in an app I've done that before and had 2 singleton components. So what can we do to work around that? We've recently released a package called dagger.android and a support package as well, which adds these different Dagger prefixed framework classes. So we have Dagger activity, Dagger application, and the whole slew of different classes. And the point being here is it separates what actually injects and inlines a static injection method, which we'll see in a second how you register the injector, but really takes a lot out of your activities, your fragments, and makes them a lot simpler. So here, instead of just calling in that injection code directly, we're going to extend these different activities. And if you have a complex app hierarchy, there are examples you can copy exactly what we're doing. It's pretty trivial. And then down below, we have this contributes Android injector method. So if any of you have ever written a subcomponent, what this is essentially doing is it's some syntactic sugar for a subcomponent which will inject the return type login activity, and you can add any modules that are specific for that subcomponent and move on with your day. So if you have 10 different activities, a different combines Android or contributes Android injector for each of those, and all of a sudden your app can be injectable. I'm not going to go into too much more detail here. There are docs on the GitHub website. The point being here is that everything should be very, very simple. If you're not finding that, please reach out to us. But this should decrease the amount of code that you have to write a lot. One thing that's very nice about this is that you no longer are hard coding against the droidCon app. If you have a test app, test application instance, debug application instance, you're not dependent on any of those, and we'll see why that's important in a few minutes. So here's the full list of classes that we have. So under the hood, this is the activity that, the subcomponent that it generates, and you can look into those actual types directly if you care, but they're sort of just boilerplate. So lastly, let's look into building faster with Dagger, because I know all of you want Dagger to be infinitesimally small when you build in Java-C. So the key here is compile as little as possible, right? Dagger is a very intensive annotation processor. There isn't much we can do to get around this. We've tried to generate more ahead of time, but at the end of the day, we need to know almost your entire class path. And anytime you change any little bit of that, we need to regenerate a lot and do a lot of analysis. The reason, obviously, is so that we don't do that analysis at runtime, but you're hitting that at compile time, and that's very costly. So whenever you can, try and compile as little as possible. So going back to what we mentioned with dagger.android, if you can use Dagger activity and Dagger fragment and not hard code against an application instance, you can assemble lots of different application instances. You can have one small Gradle module which only has the login activity and let's say your first view activity, and you can have another one that's already logged in and has a specific feature and just jumps right there. And you're just going to be compiling a lot less code. Yes, you're going to have lots of different components, but those should be pretty simple to just assemble, and you're going to get a big improvement in developer productivity. So the first note here about subcomponents, we initially did not have any subcomponent concept in Dagger. We had component dependencies, and people wanted to have all of their bindings from the component be transferred. So we said, okay, we'll create this subcomponent API, which is great. Everything is generated together, but now you have that cost for all of your of having everything being generated at once, which is something we're trying to remove. So subcomponents definitely have their use, but let's see some cases where we can maybe go back to component dependencies and get those savings back. And if you're wondering exactly why subcomponents have to be inner classes and compiled together, I'll refer you again to that talk that we gave at Square. So again, we're going to have this networking component that we had previously. And that is exposed as just an OKHTTP client, right? There probably are lots of bindings and RPC interceptors that you need to configure that. But at the end of the day, we just want to expose that one binding. For the sake of this component, we don't care if it's scoped. We just want that OKHTTP client. And anything that is necessary, it doesn't really need to be pushed down to any children components. So that's all we're going to expose. And that's the only binding that gets passed across. Then we're going to have an app component which has many other bindings, maybe subcomponents, and it depends on this networking component and exposes an API service. That API service is probably going to need an OKHTTP client, but the good thing about structuring your code like this is that you can separate these into two different compilations. Now, if you were to change anything in your app component compilation, that's going to be one entirely separate compilation. The Dagger networking component is already going to be generated, and you're going to be saving yourself a lot of cost. This works really well if you have segmented parts of your graph and you're able to understand those pretty well. If you have a lot of interconnected parts of your graph, you're probably not going to want this. But I think often we look at subcomponents and they're very convenient, and we just say, okay, subcomponents everywhere. And we forget that component dependencies, in addition to potentially making our developer productivity a lot better, are actually from an API perspective a lot more clear, because we have exactly the bindings that we're exposing. And when you have a massive graph, you don't want just every little binding of a string or something to be leaked into other components. So using component dependencies, you have a very explicit API that you're defining within your app. So here, again, this is the Dagger app component, which just gets generated once. And any code that depends on that gets that same compiled class files, doesn't need to recompile. And if you're compiling fractions of your code, you're just going to have much faster compilations. So to summarize, read the generated code. If anything looks weird, if things are taking a long time, reach out to us. Let's suggest new ways to improve Dagger. And thank you. We'll do a few minutes of questions. If you have anything that is specific to your code that you don't want to share with everyone, you're nervous about not understanding Dagger or about having something in Dagger not work for you, there's my email, there's my Twitter handle where I'll tweet out the slides. And I'll be around all day, happy to debug your code or just talk Dagger. And if today doesn't work because you're in talks, send an email. We can get on Google Hangouts and discuss. Thanks, everyone. Any questions?
There were a lot of good suggestions how to improve code. Are there any idea or plan to have some linter plugin so it can actually show you, I see you have I don't know, this lazy injection and you can avoid it. Do you plan for some static analysis for this to have preemptive optimizations?
Yeah, we're looking into the possibility of having an error-prone plugin, which I sort of alluded to but didn't really discuss. If you're not using error-prone in your builds, you're making a huge mistake. I'm sure we'll catch at least one bug in your code already, and you can create a lot of extensions on top of it. So we're looking to create an extension to do something to detect lazies. It's very difficult because you need full knowledge of every type in your hierarchy, and we don't often know if if something has state which is relevant. But we are thinking about it. If you have ideas, that would be very helpful. Any other questions?
So my question is with this contributes Android injector. You showed some code sometimes in the app you would, in order to inject activity, you would go grab the application, cast it to your type of application, get the component from it. We do that sometimes because the application is a singleton object. That's where we put the components. But reality is there's no need for that to be in the application object. You can just take any singleton, call it injector or something, and make it available. And then you don't need to use the application object at all, and then that makes it possible to use it in your JVM test, you don't need the application object at all. So with that in mind, do you need this contributes Android injector annotation? Can you just build your own graph with your own components?
Sure. So you definitely could do that. The one pitfall with any static state is you're tying your implementation directly to that reference, right? So if you want to have any different type of component, you're going to have to be able to set that in a potentially confusing way, and you probably want to be able to refer to a bunch of different component instances, which may have different types, and you may have intersection types. So it might not always be so clean. Sometimes you might want your test component to expose a little bit more, and this static reference that you're storing somewhere isn't going to be having that explicit Java type. We often overlook the fact that components in Dagger 2, I'm going to finish. Components in Dagger 2 are just regular Java types. So if we declare just our regular component and not a test component, we're going to lose any additional type information that we have there. Happy to continue discussing outside with anyone that's curious. Thanks, everyone.